Hello, everyone, and welcome to our monthly Dr. Spotfire live session, in which we have the opportunity to present demos, use cases, and talk with industry experts. I am your host, Jose Aguirre, and today we have Glenn Hosking from the R&D team, and he's going to talk about Spotfire streaming, which is all about real live data. You want to say hi to the audience, Glenn?
Hello, everybody. Thank you for inviting me, Jose.
All right. Let's go to the next slide. So this is just a quick confidentiality announcement. Go to the next one. I want to take this opportunity to, before we continue, to quickly share a product update. So you remember that Spotfire Data Science, well, is now called Spotfire Industry Pro. And this name change reflects our commitment to industrial organization facing high-stake decisions and fragmented data. Spotfire Industry Pro is a visual analytics platform powered by AI-assisted intelligence designed for cross-domain collaboration. Next slide. So by uniting interactive exploration, industry analytics, and explainable AI in one governed environment, we enable experts to move from insight to action without switching tools. Our mission remains the same, helping your team make better decisions faster when it matters the most. So, in other words, Spotfire Data Science is now called Spotfire Industry Pro to align with the industry needs. So, next slide. Learning is not driven by answers, but by questions. So that's our motto. So keep the questions coming. Questions spark curiosity, challenge critical thinking, and drive the deeper understanding necessary for true growth. So keep the questions coming through our channel, LinkedIn or YouTube, if you're watching from there. Okay. And well, we have, I'm pleased to have Glenn Hoskins, Principal Solution Architect. He works for Spotfire in the research and development team. So welcome, Glenn. The floor is yours.
Very good. Thank you. So today we're going to talk a little bit about streaming in the context of how it's used with Spotfire. So streaming is a little bit different than the standard Spotfire use cases, where you're usually looking at data that's been sitting in data lakes or databases or data repositories that are static. Streaming data is moving, so it's live data. So it's a bit more exciting and more interesting, and we can find some insights in that data. So we'll talk a little bit about what is streaming first, and I'm going to show you a demo of something called the Drilling Accelerator, which is used in a use case for monitoring telemetry from drilling rigs in oil and gas. I'll show you a little bit of an architecture diagram of what that looks like. And then last, I'm going to do another demo of something called a Data Replay Accelerator. That's a little bit different in that it's not really a true live connection, but what it allows you to do is take recorded data and replay it in a way as if it was happening live, so that you can help with troubleshooting issues that you may be observing in telemetry data. So to start with, let's talk about what is event stream processing. So these days, people talk about stream processing, and if you're familiar with Kafka or Pulsar, that seems to be the de facto standard technology for event stream processing. But it is a broader set of technologies that kind of exist across a wider space than just those two products. But the key features of it is that we're looking at continuous data set integration. So data at rest, which is databases or data lakes or data warehouses, versus data in motion. So data in motion are happening in real time. They occur as discrete events. You don't pull those events, you're listening to those events. Generally, it follows what's called a publish and subscribe model. So you register a listener, and then you receive the events pushed at you. You don't actually pull them. The idea is that you have real-time insight into what's happening. You can use it to detect patterns, calculate aggregations, trigger automated responses, all kinds of insights and actions that you can take in response to that information. There's the concept of complex event correlation, and complex in this scenario doesn't mean complicated, although it is complicated, but complex means that events don't exist by themselves. They exist in an interrelated or interconnected world. So one event might link to other events of different types. It might event to data that's stored in a repository as well. So that complex correlation of those events across that broader ecosystem is what event stream processing is about. This is different than what's called simple event processing, where you have one single event, which consists of one set of data. You process that single simple event in its own little world just by itself. Complex event processing is taking a single event and then looking at how it fits into the broader ecosystem of information that you have available. Another key feature of event stream processing is you have decoupled architectures. So this is where this publish subscribe model comes from. You register listeners on things like Kafka or Pulsar or a message bus, for example, in JMS. And then those events get pushed at you and you're decoupled from the source of the events. You're not actually impacting the performance of the source of those events. You're just a passive receiver, and then that middleware sits in the middle as a mediation layer. So it's a lot of different features in event stream processing than it would be in a traditional static data source that you'd have available. So where does Spotfire data streams fit into this? So if you look at, we're going from the left to the right here. On the left-hand side, we have a number of data sources that we'd have live streaming data coming out of. And there's a number of different connectors that we have available for that. So the common ones, like I said, are Kafka and Pulsar, but it could be MQTT IoT data streams. It could be GPS data from equipment or vehicles moving around. It could be data coming off of market data in the case of financial information. There's any number of different sources that we could plug into here. The data flows into the streaming analytics layer, and inside of that, we do a number of different things. We can do rules and events on those events. We can do aggregations on those events. We can do decision tables on those events. We can make decisions on those events and do different things in response to it. And that's what's coming out on the right-hand side. So from Spotfire's world, we're looking at the top one up there, which is the visual analytics. So that is going to be a live analytics viewport into the world of the event streams. So we're going to look at both real-time and historical data in Spotfire. And we'll see charts that are going to update in real time as they're going through. So it's a bit different than a regular Spotfire chart where it sits there statically. These are actually going to be what I call dancing charts. So we'll see lines moving and various things changing. But we can do things like publish alerts and take action, so we can notify staff that something needs to be done. We can do automated integrations with other systems. And then finally, we can provide this information as a service. So not only are we collecting the data on the left-hand side, we can also republish it as event stream APIs on the right-hand side as well. And then if you look at the top and bottom of that streaming analytics box in the middle, on the top, we have the users who are looking at it, and there's a wide variety of audience that can benefit from this sort of technology. Generally business analysts, domain experts, scientists and engineers, developers and IT as well. And then on the bottom side, you see some of the static sources that come into it. Oftentimes you're plugged into something like a data virtualization historical repository that then branches out to a number of different sources. That might be your big data lakes, might be your ERP systems or CRM systems or engineering systems, any number of different things that have static data that provide context to those events. So that's part of that complex event processing. We can also do things like data science models, build things in Python or R or languages like PMML, bring those into the streaming layer and do real-time data science in response to those events as well. So that's event stream processing and how Spotfire uses event stream processing. And finally, why it's important. So really what allows you to do is something called continuous intelligence. So instead of passively going out and identifying patterns of interest and trying to identify anomalies manually or through automation, but in a reactive manner, what allows you to do is take proactive actions in response to events happening. So you set up the monitoring, you set up the rules, you set up the data science models to look for things that are of interest, or to look for anomalies, to look for unusual things that it can identify, and then take action in response to that. So it's continuous intelligence. We're also learning in response to that as well. We can update those models and those data decision tables in response to things that we identify all in real time. So that's a bit about how it kind of sits together. Now I'll show you a little demo because it's always interesting to look at a demo as opposed to look at slides. So let me pull this up here. This is called the IoT Drilling Accelerator, and it is used in oil and gas for monitoring drill rig performance and drill rig operations. So this is an accelerator that we distribute for free on Spotfire Community. If you go into the Exchange section of Spotfire Community, you'll see a section called Accelerators, and this will be one of them that you can download. Sitting in back of this is Spotfire we're looking at here, a DXP. There's something called Spotfire Data Streams, which is the live streaming component part of this architecture. I'll show you an architecture diagram after I do the demo, but that's the other product that's being used as part of this. I'm going to do this as a simulation. In real life, this would be hooked up to a data repository called a WITSML data repository, which is a standard in oil and gas, particularly in drilling, for integrating with drill rigs and drill rig data. That data would stream out and then into the streaming layer and then into Spotfire. So I'm going to do this as a simulation. I'm going to start up my little simulation here. And we'll let this run. So you can see a number of visualizations here. We've got a map. The map isn't live at the moment. It's just plugged into static data. But all these other ones are live. So we've got here a text area with some values in here. These are showing current values of where the bit is at the point of the operation. The depth of the hole, so you can see the bit depth and hole depth are the same. So this is called making hole. We're at the bottom of the hole drilling at the moment. And then this thing here in the middle is doing a classification of what the rig is doing. So the rig doesn't literally tell you what it's doing. We need to do some interpretation of the data that we have available to do that. And that's one of the value adds that the streaming layer is doing here. So the streaming layer is receiving all of these metrics, and there's lots more than these. There's 9 shown here. There's 20 or 30 or 40 in some cases. There's a decision table that looks at those metrics as they flow through, and it classifies what is the rig doing at any given point in time. And it will tell people monitoring using this dashboard or using this analysis what the rig is doing. So at the moment, it's rotating. We've got some key values here. This is called rate of penetration, weight on bit, rotary RPM, and hook load. These are gauge visualizations, which are visualization mods that come from community. This here is called the well log mod. This is one of these industry pro visualizations that Jose was just mentioning before. And what we're showing here is vertically oriented charts of these key metrics indexed by a time index on the y-axis here. These have been arranged into what's called tracks. So the block height, weight on bit, and rate of penetration are on this first track. And then likewise, these are separate tracks. And we can do some reorganization of how this is arranged.
I have a question then.
Yeah.
So, for example, the data that is coming in, it seems that it's being accumulated. Is there a window, like on a time where the old data that you can define, that the old data goes away and then fresh data coming in? Okay.
Yes, that's very common. So time windowing is quite commonly used in here. So at the moment, this is going to show the life cycle of a single run of a go in hole and then pull back out again. This is doing some time compression as well. So in real life, it doesn't go this quick. But that is essentially what it would do. So with this case, usually you would show the life of one of those runs, and then you would combine that with historical data from a static repository of previous runs. And then that's the next bit, is you can build dashboards that combine both live data as well as that historical data. So you can see what happened before, what happened at wells in other areas nearby, and see how and compare with the operations that you're running. So in addition to these live parameters, we can look at what the hole looks like in real time as it's drilling. This is a 3D visualization, which is again another one of the industry pro visualizations that we have. In this case, it's showing the red line, which is the plan, and then the blue line, which is the actual. So if you kind of, well, it's going to deviate a little bit. If I zoom in and kind of pan over, we might be able to see it. But it should show you how there's some deviation from the plan here, and this would then be an alertable scenario. So you can see this blue line is deviating a little bit from the red one. So pretty much all of these visualizations are live enabled. So we can point them at live streaming sources, the same as we would any other one. If we look at the data canvas here, you'll see they're called Spotfire Data Streams connectors. So it's very similar to other in-data source data tables that you would have.
So basically what you're saying, Glenn, is that any visualization can take the data, the live stream data. It's not about the visualization per se. It's more about the data source.
That's right. So you can think of this, it's the same as if you were connecting to, say, an in-source database source. You can think of it as very similar to that. So these are in-source data sources, but they're data streams. So likewise, so if you're using like an Oracle data source, your data functions change a little bit in Spotfire because it's exposing the functions that are of the underlying data source. The exact same thing happens here. So the functions you would have available would be slightly different because they're using the Spotfire data streams as the data source. And the way these things are working as well, there isn't many streaming dashboards, analytic tools. They actually do pulled snapshots from data sources in the background, which is not particularly efficient. The way this works is that everything is all event-oriented. So the events coming right from the beginning go through the streaming layer, and the events are actually pushed into this client in Spotfire at this moment. So what it's actually doing is it's saying, I'm going to tell you what's changed every second or every time something has changed. It's sub-second in most cases. So it's not sending you this entire table every time. It's just saying, I have a new row, I have a new row, I have a new row. And then Spotfire responds to that by re-rendering this visualization in response to that new row. But we're not doing full snapshot, a full query of that table every time. So this is how it's the most efficient way to deal with event-oriented data. So that's the drilling accelerator. I'll show you a bit about what that looks like in terms of an architecture. So if you look at these kind of blue boxes here, these are what's called Spotfire streaming or Spotfire data streams. There's different names and different flavors of this product that are available as well. So TIBCO streaming is kind of the full version of the product. Spotfire data streams is a limited version of the product. Functionally, they're identical, but there are license restrictions on what you can do with Spotfire data streams versus TIBCO streaming. So if you are planning on doing something with streaming, make sure you kind of talk to your TAM or your CS just to make sure that you're covered license-wise, because there are some limitations. So again, on the left-hand side, we've got our data source, which would be a drill rig somewhere on land or offshore. They usually integrate with something called a WITSML repository. So there's various vendors sell these things, and it is a standard. WITSMLs have been a standard for about 20, 25 years. We have connectors built into the product that connect to that, those WITSML sources, and they pull the data out of the WITSML source, do some transformation on it to get it into the format that it can be displayed in Spotfire. It calculates the rig state. So is it drilling? Is it sliding? Is it running pumps? So we can look at what's actually happening at any given point in time. There's different types of rules and filters that are going on in here. We're monitoring for KPIs, so make sure that rotary RPM is within tolerance. We're not seeing anything anomalous in there that could lead to failures. And identify exceptions when things aren't happening to plan. And then we publish notifications in response to that, which can be pulled by operations engineers. So not just in Spotfire, but we can send emails or we can send text messages or notifications to mobile apps or mobile devices. The Spotfire streaming real-time data mart, this is the bit that Spotfire connects to. So normally these two run as two different types of engines because they have different use cases, how they're used. This tends to be CPU oriented. This tends to be memory oriented. So it's very common to deploy them as two different engines on two different sets of hardware that are optimized for the use case of what they need. There is a layer in the middle for artifact deployment. So if you wanted to update the rig state decision table, for example, you can use this as an intermediate layer to do that. You can deploy updated versions of those rules using this, or data science models as well. Python models can do this as well. You can do that without restarting this engine. So they're pushed into the running engine without having any downtime. And then the red box, this is our Spotfire analytics. So Spotfire Industry Pro. And that was what we were just looking at there as the DXP. And this is where you have, operations engineers and data analysts will sit and use this and monitor the operations, usually remotely, of what a rig is doing at any given point in time. And again, this is often integrated along with a historical repository, which might be plugged into a data virtualization layer. So again, we're looking at live data for a single run of a rig, but we might have historical data for other wells in the area, other runs of that individual well, so that we can compare that live data with what is going in historically as well, and then identify, potentially anomalies in that. So this is Yeah, so this is the architecture of what we just looked at there. So the next bit, I'm going to do another demo, and you might be thinking, well, I don't really have live data, which is quite common, actually. I mean, real-time live data often happens in certain circumstances where you've got instrumented machinery, so things like drill rigs that are highly instrumented and highly integrated with event processing layers. That doesn't necessarily always exist. Oftentimes, we only have data historians. We have things like Aviva Pi or OPC UA systems where we have lots of sensor data that's been recorded, but it wasn't captured in real time as it was occurring. So we weren't able to monitor things that were kind of being anomalous. So let's look at this from the scenario of what if we could then replay that data. If we identify anomalies, what if we could then replay that data and identify patterns that were leading up to that anomaly occurring? How could we make use of something like streaming in order to simulate that environment? So like I just showed a simulation of drill rigs, this is a slightly different simulation. What we're going to do here is monitor for anomalies occurring in a stream, but it's only a single metric. So I'm running a simulation here. Let's keep an eye on this up here. When an anomaly is detected, it's going to create an entry in this trigger table. I'll just pause this here so that it doesn't run. You can see at the moment the status says it's created. So the way this is configured is it identifies situations that are anomalous. When it occurs, it creates a trigger. But what I've done is I've defined a window before and after that trigger where I'm interested in some related data that is occurring. That data is not real time. It's going to exist in my historical repository somewhere. Maybe it's an Aviva Pi system or an OPC UA compliant system or a database even. So in this instance, it's created. I'm going to say I want 10 minutes before and 20 minutes after what happened there so that we can see what actually was going on. So at the moment it's created. If I run this some more, it will eventually go to the status of ready. At this point, now that time period has elapsed. Again, this is some time compression here, so we don't have to sit here for 30 minutes watching it. But that time window has now elapsed. So if I select this in Spotfire, you can see there's a little panel in here called the replay control. So it's telling you what triggered that. There was a tag in a Pi system that triggered it, when it triggered, and then the time window that I have available. So in this case, it's 20 minutes before and 10 minutes after. So it's 2010, but get the idea. So now we have some controls here called start and clear. So if I click the start button, it's going to go off and start preparing a simulation by going out to the Aviva Pi system and retrieving all of the related tags that were configured in response to this. So if I select this here, and now it's going to then start replaying those tags in kind of a simulation. Spotfires. There we go. So it's replaying those tags now as a simulation so that we can see what happened in those other metrics leading up to the anomaly that occurred in the one metric that we were monitoring. So these, again, are gauges that are looking at what the current values are. You can see the red line here is the one that we monitored. The green vertical line represents the anomaly point where it happened, and you can see the red line is dropped below 50 at that point. That's the condition that I configured as being a trigger. So once that condition occurred, what it then does is retrieves the 10 minutes before or the 20 minutes before and the 10 minutes after that point. So if you see kind of this period of time and this period of time, and then these other metrics are related to that. And we can see there's some other patterns going on in here. These two metrics are reducing around the same time that the power in is reducing as well. So this might be interesting from the point of view of an engineering standpoint to be able to troubleshoot what was going on in this system at this time. And again, this can be configured with any set of metrics that you'd want, and it's driven by a decision table as well. So I'll show you what that looks like. This, incidentally, is the authoring environment for streaming and Spotfire data streams. It's a drag and drop type environment where you're dropping nodes onto a canvas and then wiring them up together with arcs, and then doing some mappings in between them. But this is called a decision table. This is showing you what is using the conditions to be able to identify the patterns. So it's looking for a tag, it's looking for a value match where value is less than 50, It says the window lower and the window upper that I want to retrieve in response to that occurring. So 20 below and 10 above. And then there's a list of related tags to go along with that. So when that trigger occurs, I can then control the rest of it. So the only thing that's being monitored in real time is this trigger tag. These other ones are all being retrieved as a snapshot from the repository where the other tags are stored. So again, Pi system, OPC system, database, you name it, anything like that. So that's a slightly different use case for streaming. It's not really true real-time streaming anymore, but it's a replay scenario of some historical data. So you get almost like a live view of things that are happening. You can also control the time compression on that as well. So speed it up, slow it down, pause it, resume it as it's going through. All those are controls inside of the Spotfire dashboard that we just looked at. And that's about it.
All right, I have a question that people in the audience might have, which is, can you deploy using containers?
You can. So it supports various types of deployment environments. You can deploy it on a bare metal environment. You can deploy it in virtual machines. Those that we were just looking at were EC2 and AWS. It supports Kubernetes and Docker containers as well. And it's very common to do that. And like I said, you often deploy the two different parts of it in two different ways. So you might have nodes that are CPU optimized for the event manager and nodes that are memory optimized for the real-time data mart component.
Okay. And what are the common connectors that Spotfire connects to when it comes to real-time?
Yep, there's about 100 odd different connectors in the product. It's fairly comprehensive what's available. So very common ones in sensor data, for example, are MQTT, Kafka, Pulsar. All of those are supported natively. There are very specialized ones for historian systems like Aviva Pi and OPC UA. And again, both of those have streaming interfaces, not just query snapshot type interfaces. They're actual real live interfaces. And then there's a variety of other messaging middlewares are supported. So JMS, FTL, Rendezvous, RabbitMQ. Overall, there is almost 100 adapters to my recollection. So, and they support both inbound and outbound messaging.
Very nice, very nice. Okay, thank you very much, Glenn. That was a very insightful session. So we're running out of time. If you don't have any other questions, well, join us for Dr. Spotfire office hours the first Tuesday of every month, and subscribe to our Dr. Spotfire channel in YouTube. Is youtube.com/@Dr. Spotfire, and you will see the previous recorded sessions. You can also go to the community, and there's a section there for Dr. Spotfire, so you can see what's the upcoming session or the events in the community of Spotfire, community.spotfire.com, and there you can also see previous sessions. And if you have any questions on this one or previous sessions, you can always watch the record, and you can always ask your comments or your questions there. Next slide. The community newsletter, you're welcome to join, scan the QRC code, and you will see what's new, what the updates, more details on the name change and things like that, upcoming versions, education and certifications, quick tips, all of that in one place quarterly on the community newsletter. And I think that's it. Oh, well, just subscribe for the recorded sessions. As I said, the YouTube channel is at drspotfire.com. Every Tuesday at this time, 11 Central, the first Tuesday of the month. And that's it, guys. Thank you, and see you next time.
Thank you.